In this video, I want to introduce the idea of hybridization. So to do that, I'm going to look at methane. Methane has the chemical formula CH4, and it's tetrahedral in shape. If I wanted to draw the covalent bonds, a representation using orbital filling diagrams, what I would have to do is I'd have to start with the carbon. So that's 1s2, 2s2, 2p2. And I'm just going to fill in those electrons there. Up, down, up, down, up, up. And then I'll want to show the fact that it's bonding with 4 hydrogens, and I'm being a little bit lazy here. Each of these hydrogens is 1s1, and I'm going to draw these electrons as downward spinning so that when I make bonds, that they'll have the same shape. So I could bond this one, that would give me 2 electrons, and I would give this one, and that would give me another 2 electrons, because we know that a covalent bond is a pair of shared electrons. However, when I look here, I can't bond those 2 electrons with the remaining 2 hydrogens. So I might think to myself, well, maybe I'll take this electron and I will promote it to the s orbital so that I can form another bond here and another bond here. And you would think to yourself, great, I've drawn my filling diagram, I'm done, this is fantastic. However, you've got a problem. The problem is that the 3 bonds shown in black are the same shape and size because they're bonded between an s and a p orbital. However, the bond between the s orbital here in carbon and here in hydrogen would be a different shape and size. But we know from studying methane that what actually happens is that all 4 bonds are the same shape and size. So there's got to be something going on. What this means is that we need to go back to the drawing board in order to figure out a brand new way of drawing it. So again, thinking of our carbon with its tetrahedral shape, I realize it has a steric number of 4. That means that when I make my bonds, I'm going to want to have 4 bonds that are exactly the same. That's going to mean taking these 4 orbitals and hybridizing them, mixing them together to form something new. The 1s orbital doesn't change, but what actually happens is that the 1s orbital here and these 3 p orbitals form a hybrid orbital. They fuse together and they form something that's kind of in between an s orbital and a p orbital. The electrons in the 1s2 orbital stay the same, but the electrons in the 2s2 and the 2p2 orbitals are now hybridized to this sp3 orbital. So each of those electrons is occupying a cloud of the same shape and size, which means that when they now bond with these 4 hydrogens, again each of them being 1s1, what we'll see is that each bond is going to be exactly the same shape and size.